Hello everyone. In this video we are going to go over the last way of solving systems of equations, and that's an algebraic method called elimination, where we're going to eliminate a variable in order to solve for one variable at a time. Alright, so you might be asking, how are we going to eliminate? So in example 1a, we've got this system, x minus 2y equals 7, and 3x plus 2y equals 13. Alright, if I wanted to leave it as it is, how can I eliminate a variable? Well, if you'll notice, we have negative 2y and positive 2y. So if I add these two equations together, x plus 3x is 4x, negative 2y plus 2y becomes 0y, and 7 plus 13 is equal to 20. The y's got eliminated because 0 times y is just 0. So I'm left with 4x equals 20, so x equals 5. We solved for one of the variables. Now I'm going to take that 5 and plug it back in for x into either equation so that I can solve for y. So I'm going to plug it in the top. So I got 5 minus 2y equals 7. I'm going to subtract 5 from both sides. So I got negative 2y equals 2. Divide both sides by negative 2, I'll get y equals negative 1. So the ordered pair, the solution here, the intersection point of these two lines is 5, negative 1. Okay? And I can check that. I can check that in the second equation. 3 times 5, plugging in 5 for x, plus 2 times y, plugging in negative 1 for y, equals 13. Let's make sure this works. 3 times 5 is 15. 2 times negative 1 is negative 2. 15 plus negative 2, or 15 minus 2, is 13. 13 equals 13. It works for the second equation, therefore we know it's the solution. Okay? So those y's were all ready to be eliminated. Those were opposites of each other. So when I added them together, they went away. Okay, what about in example B? If I add these equations together, I'm going to get 9x minus 15y equals 18. None of my variables got eliminated. So what can I do here? All right. Well, what happens is we can manipulate our equations in order for us to get opposite coefficients like we did in example A. In order to get like a negative 2y and a positive 2y. So when I add them together, they go away. You need to ask yourself, what variable do you want to eliminate? It does not matter which variable you want to eliminate. I'm going to choose the x's. So look at the terms involving the x. We've got 3x and 6x. All right? How can I get these to be opposites of each other? Well, I can make the 3x become negative 6x. Okay? How can I do that? Well, we're going to multiply this top equation. We're going to manipulate it. We're going to multiply it by negative 2. Okay? It's still going to be the same exact line. We're just multiplying it by a nice number. So negative 2 times 3x becomes negative 6x. Negative 2 times negative 7y becomes positive 14y. Negative 2 times 10 is negative 20. It's the same exact line. I just multiplied it by a number. All right. The bottom equation I'm going to keep as is. 6x minus 8y equals 18, equals 8. Now these equations are ready to be added together. Because if I add these two equations together, the 6x gets eliminated, or the x's get eliminated. Then we got 14y minus 8y. That's going to give me 6y. And negative 20 plus 8, it's going to give me negative 12. All right, divide both sides by 6, y equals negative 2. All right, so we got the y coordinate. Now we need to plug it into either the top or the bottom equation to solve for x. I'm going to plug it into the top. So I got 3x minus 7y, but instead of y, I'm going to substitute in negative 2, because that's what we just solved for, equals 10. So we got 3x plus 14 equals 10. Subtract 14 from both sides, so I'll get 3x equals negative 4. Divide both sides by 3. X is going to equal negative 4/3. Okay? Fractions are decimals too, so that's fine. The solution, as we have it right now, is negative 4/3, negative 2. All I need to do, my calculator is going to help me out here maybe, is check it in the second one. All right, so I've got 6x, but instead of x, I'm going to plug in negative 4/3, minus 8y, but instead of y, I'm going to plug in negative 2, and I'm going to make sure that that equals 8. I'm going to make sure that this equation is satisfied. So 6 times negative 4/3 is going to give me negative 8. Negative 8 times negative 2 is positive 16. Negative 8 plus 16 is 8, so 8 equals 8. It works for the second equation, therefore I know that this solution is the correct solution. All right, so like in example 1a, we were able to just eliminate a variable right away. In example 1b, we had to manipulate one of our equations in order to get opposite coefficients, therefore we could eliminate a variable. All right, what about in 1c? Are any variables ready to be eliminated right away? No. No, I don't have opposite coefficients. What about, could I manipulate one of my equations to get opposite coefficients? Not off the bat. Okay, so maybe I need to manipulate both of my equations. All right, so you have to decide what do you want to eliminate, the x's or the y's? And then your goal is to get opposite coefficients there. Okay, so if we wanted to eliminate the x's, what do 2 and 5 both go into? Well, they both go into 10. Okay, so I could multiply the top equation by 5 and the bottom equation by negative 2. That way, the top equation becomes 10x plus 15y equals 45. And the bottom equation becomes negative 10x plus 8y equals negative 22. All right, we got to distribute that number across the entire equation. And then, if you add those together, you would eliminate the x's. All right, what if you wanted to eliminate the y's? So let me get rid of this stuff. Well, our y's currently are 3y and negative 4y. So what number do 3 and 4 both go into? They both go into 12. So I could multiply the top equation by 4, because that's going to become 8x plus 12y equals 36. And if I multiply the top equation by 4, I'm going to multiply the bottom equation by 3, so that it becomes 15x minus 12y equals 33. All right? And notice if I add the equations there, the y's would cancel out. Again, it does not matter which variable you eliminate. You just got to decide and then manipulate your equations correctly. So I'm going to go ahead and eliminate the x's. I'm going to finish this problem by eliminating the x's. So if I add these together, my x's go away. 15y plus 8y, that's going to give me 23y. And then 45 plus negative 22, it's going to give me 23. So y will equal 1. All right, so now I'm going to plug that back into either the top or the bottom. I'm going to do the top and solve for x now. So I got 2x plus 3y, but instead of y, I'm going to plug in 1 because that's what we just solved for, equals 9. All right, so 2x plus 3 equals 9. 2x equals 6. X equals 3. So my solution here is 3, 1. All right, and then I can test that solution in the second equation to make sure it works. 5 times 3 minus 4 times 1. Let's make sure that equals 11. We've got 15 minus 4, which equals 11. So that works for the second equation. Therefore, I know that that is the solution to the entire system. That's where they intersect. Okay? So that is the process of elimination. You just got to decide which variable you want to eliminate and then manipulate your equation so that you have opposite coefficients. So one has to be positive, one has to be negative, and they got to be the same number. All right. In the next video, we'll tackle problems D and E because those are our special cases. If you have any questions, please let me know. Tune into the next video.